Okay, we are on our last section of the semester. This is 2.8, composition of functions. And to make things go a little bit smoother, I've color-coded. I hope the color coding shows up on the video. But I've made my F function purple, my G function orange, and my H function green. And for the first problem, we have F plus G of X. Basically what that means is that I'm going to take my F function plus my G function. So my F function is x squared plus 6. Then my G function comes from here is 3x squared minus 2x. And then what we're going to do is combine like terms. 1 and 3 is 4x squared minus 2x plus 6. Now for my domain, a few things I need to consider when I'm looking for domain. One is if there's a denominator. I don't have a denominator here. The second one is, do I have any kind of radical? And I'll put the radical. I have no radical. And then the third thing I look at is, what kind of function is it? This is a quadratic function because it has a degree of 2. And I know a quadratic function is a parabola, which is going to be a U shape. This is positive, so it goes up. So I know my domain goes from negative to positive infinity. I don't have to graph it. I know enough about quadratics to know that the domain is going to be negative to positive infinity. The next page, we have the same things, and I'm still going to keep the same color system: purple, orange, and green. Now we're subtracting G and H. That means I'm going to take G of X and I'm going to subtract H of X. So my G of X is 3x squared minus 2x, and it's minus my H of X, which is 4x plus 7. Notice I put it in parentheses. We didn't need to do that when it was addition because the addition wasn't going to change anything. But when we have subtraction, we're subtracting all of H of X. So I need to make sure I distribute the negative, and the best way to make sure that I do that is to put it in parentheses. So then when I distribute that negative, I get 3x squared minus 2x minus 4x minus 7. And then I combine like terms, and I have 3x squared minus 6x minus 7. And then when we go to look for the domain, this is another quadratic, and we know that that's a parabola, so my domain goes to negative to positive infinity. Okay, next one. We have F times H. Notice that this is a closed-in circle for times. That's going to matter later. So I'm taking F of X times H of X. So that means I'm taking my F of X, which is x squared plus 6, and I'm multiplying it times my H of X, which is 4x plus 7. And what I need to do is distribute every term or FOIL it. X squared times 4x is 4x cubed. X squared times 7 is 7x squared. 6 times 4 is 24x. And 6 times 7 is 42. I don't have any like terms, and it's in standard form. The exponents go from largest to smallest, so it's in the right form. And then I've got to figure out whether what my domain's going to look like. And again, I have no denominator. I have no radical. But what I do have is that it's a cubic. And what I remember about a cubic and its parent function is it looks something like that. Well, that's going to go from negative to positive infinity as well. So that's my domain, negative to positive infinity. And there's no restrictions on it because I don't have a denominator or a radical. So I bet that most of you probably know what comes next. But this is going to be G of X. And I'm going to put that over H of X. So my G of X function is 3x squared minus 2x. And my H function is 4x plus 7. And you want to make sure that you always factor so that if there's something that can cancel, that you see that. So this is x times 3x minus 2. If I take an x out of that, there's really nothing I can factor out of the bottom, so that's 4x plus 7. Now I have a denominator. Okay, and when I have a denominator, I'm going to have a domain restriction. And so my domain restriction, what that means, remember we can never have 0 in the denominator. So that means that 4x plus 7 cannot equal 0. Subtract 7 from both sides, I get 4x equals negative 7. When I divide by 4, I get cannot equal, and cannot equal 7, negative 7/4. And I always show my class what that looks like on a number line. So what that means is negative 7/4 cannot be the answer, but it can be everything else on either side. So that means that my domain is going to be negative infinity up to negative 7/4 with the parentheses because we're not including it. And then we're going to go from negative 7/4, not including it, out to positive infinity. And that's our domain. All right, next one. This is another division one. We're going to take f of x, and we're going to divide that by g of x. F of x is x squared plus 6. G of x is 3x squared minus 2x. Okay, my next step, whoa, I am like way off. Let me back up here for you. Sorry about that. So I have f of x over g of x. My f of x is x squared plus 6. My g of x is 3x squared minus 2x. And then I need to factor the numerator and denominator if possible. I can't factor x squared plus 6, so that's just going to stay the same. Down here I can factor out an x, so I have x times 3x minus 2. And again, I cannot have 0 in the denominator. Each one of these factors has to be set not equal to 0, because if either one of those is 0, then the whole thing doesn't work. So this is x does not equal 0, and that's as far as I can go. This one is 3x minus 2 cannot equal 0. So 3x cannot equal positive 2, because I'm going to move the 2 over. And then when I divide by 3, I find out that x cannot equal 2/3. If I put that on a number line, that tells me that if I get positive, not negative, positive 2/3. So that means I don't have 2/3 and I don't have 0, but I have everything else on the number line. So that means that my domain goes from negative infinity to 0, does not include 0. It continues from 0 to 2/3, not including either one of them, and then goes from 2/3 to positive infinity. And so that's how you would calculate the domain on that one. You get just a couple more. Next page, I'm still going to maintain the same coloring system. So we have purple, orange, and green. You don't have to use it, but I just think it makes it easier. Now this one's different, and if you'll remember when we were doing number 3, I was talking about how the dot was filled in and that mattered. That means times. This, however, when you have the open circle, means something a little different, so you really have to pay attention. This means that I have h of g of x, and I know how much you guys love those compositions. So that means that I'm going to have h of 3x squared minus 2x. So that means if I have my h function, 4x plus 7, wherever there's an x, I'm going to put this value. So I'm going to have 4 times 3x squared minus 2x. Okay, that's my x, plus 7. So 4x plus 7. Now I'm going to simplify, and I've got 12x squared, I'm distributing to 4, minus 8x, plus 7. And there's no way I can simplify that anymore. I have a quadratic, so my domain's easy. It's from negative to positive infinity, because it's a quadratic. Your quadratics are always going to be negative to positive infinity. Okay, we have another one. There's the same thing. It's just these mean the same thing. They just have different ways of naming them. And you have to understand both. Because the open circle is just like this. So now I've got f of g of x And so I'm going to take whatever g of x is, and I'm going to put that entire expression in here. So I've got 3x squared minus 2x. This means that wherever there's an x in my f function, I'm going to put that whole expression. So that means I've got my x squared, so I've got 3x squared minus 2x, and that's going to be squared, plus 6. That's my f function. That means I've got 3x squared minus 2x times 3x squared minus 2x plus 6. And when I FOIL this, I have 9x squared minus 6x squared minus 6x, oh, excuse me, 9x to the 4th. Woohoo! We're just used to when we FOIL there's a square, but yes, because it's x squared times x squared minus 6x squared minus 6x squared, and then plus, actually those are x cubes. Woo! It's been a long day. All right. And then plus 4x squared. I'll get it there eventually. And then plus 6. Now I'm going to combine like terms, so I have 9x to the 4th minus 12x to the 3rd plus 4x squared plus 6. Okay, last one. This is like the reverse of what we just did. So I'm taking g of f of x which means I'm taking g of x squared plus 6. And that means everywhere I have an x in my g function, I'm going to put x plus 6. So that means I have 3 times x squared plus 6. And that x is being squared. Okay, I'm following this. Minus 2 times my x, which is my f function, x squared plus 6. So this means I have 3 times x squared plus 6 times x squared plus 6 minus, and you're going to distribute that through the whole thing, so it's minus 2x squared. Don't forget to go negative 2 times 6 is negative 2, 12. I'm going to multiply these two together, and I get 3 x squared times x squared is x to the 4th. I have plus 6x squared and plus 6x squared, which is plus 12x squared. I just combined two. And 6 times 6 is 36. Minus 2x squared minus 12. I need to distribute my 3 just through these parentheses. So I have 3x squared plus 36x, excuse me, 3x to the 4th plus 36x squared plus 108 minus 2x squared minus 12. And that's going to give me, when I combine like terms, I only have 1x to the 4th, so I have 3x to the 4th. 36 minus 2 would be a 34x squared. And 108 minus 12 is 96. And that would be your final answer. And so that's it for compositions of functions.